Oh, I'm sorry. I think I have not on the mic. So I'll just go back quickly. I will describe what I have done. I'm sorry. I have not on this one. Okay. So here is it. Today's class we are discussing quickly. I'll go ahead with the back slides because unfortunately I didn't on the mic. So here it is. So melting furnaces. So melting is very important process in the case of our casting process because it is the starting point of the metal casting. Okay. So you know that whenever we do this casting process, the first step is melting, then it is pouring, solidification, and then we do the casting process. So this melting of the metal melting of the metal is being done in the furnaces. Okay, so the quality of the final casting what you obtain depends upon the state at which you have melted the metal. That's why this melting is very much important, and that is being done in the furnace. Okay, so hence we should be having a knowledge of the different types of furnaces, the type of fuel used, and the type of metals that can be melted in the different type of furnace. Sorry, I'm going again back. Then you should remember that melting, there is a melting point and there is a pouring temperature. Both are different in the case of many metals. In the case of metals, it is not that at the melting temperature you do the casting operation. So melting temperature will be different, pouring temperature will be different. Pouring temperature will be slightly more than that of the melting temperature. So this is the table that depicts that. So that is there. So the next one is that the important type of furnaces what we have to discuss. So these are the important type of furnaces what we are going to discuss in today's class. We have discussed about the first one, that is the crucible furnace. So the crucible furnace is very simplest furnace. The most simplest type of furnace is this one. Here the crucible will be there, made up of cast iron, made up of graphite. You put the charge inside. The meaning of charge is solid metal. The meaning of charge is solid metal. It is being put inside, and then you pass the air plus gas inside and burn it. Inside there will be burning. The charge will melt, and then it will be taken out. There are three types of crucible furnace. First one is lift out furnace, wherein you can lift this crucible outside, take the cover out, take this crucible out and do the pouring operation. Here the crucible will be stationary. It will be tapped. The metal will be, liquid metal will be tapped from here only and taken to the point of pouring. While here you can, after the melting has been done, using this handle you can rotate or tilt in this fashion and get the pouring done. So these are the different type of crucible furnaces. Then the advantages are like this. We have discussed that in the time exchange below. Then we have seen the cupola furnace. I'll start with the cupola furnace again. Cupola furnace is the most widely used type of furnace in the foundries. It is the most oldest type of furnace which is still used in the industries. Okay, and cupola, the word cupola means, or the word cupa means barrel. So in Latin, the meaning of the word cupa is barrel. So long structure is associated with this furnace called as a cupola furnace. That's why the word cupola. It is very similar to the blast furnace. I have written that, and it is used for melting of ferrous metals. In the earlier case, that is our crucible furnace, it is basically used for non-ferrous metals. Here it is used for ferrous metals, for melting of ferrous metals like iron, cast iron and steel. So you see the construction wise, there is one shell which can be removed out, charging door through which you introduce the charging floor. This is the point at which the charge will fall and start burning. Wind box and tires are there to introduce oxygen into the into the setup. Then there will be slag sprout. It is through this the impurities, that is the slag, will be removed out, and these are the things. On the other side there is spark arrestor, stack, preheater zone. So if you want to heat the metal previously, charge previously for some high temperature, preheating can be done. Then there is a melting zone, and then there is a tapping sprout through which the liquid metal is taken out. So this is the working of our oldest type of furnace called as the cupola furnace. Now this is the point at which I had stopped. So here the advantages of this technique is that it has a simple construction, low cost is there, low maintenance is there, low money is required to operate it, and continuously you can operate this machine and get the liquid metal out of this furnace. These are the advantages. Let us focus on the disadvantages or the limitations of this technique of furnace. It is an important thing. First thing is that the close temperature control is not possible using this type of furnace. What does this close temperature mean? The close temperature means that if you are expecting the temperature to be raised to some high level of temperature, but in the case of cupola furnace, that temperature might not be exactly reached. Sometime plus or minus of that temperature will be reached. So that's what this close temperature cannot be controlled by this technique means. So in the case of cupola furnace, very close temperature cannot be, the temperature cannot be controlled to a very much close extent. So you can take a plus or minus of some 50 or 100 degrees Celsius. Okay, so that is the meaning of this first one, which is a limitation. The second one is the carbon and sulfur pickup takes place during melting. So what happens is that you have burning, or the fuel that is used here is charcoal. The charcoal is a source of carbon. So when you burn that charcoal, carbon also comes out in that charcoal and gets diffused into the cast iron or the steel component. So if you see the composition of cast iron, it is like this. So the percentage of carbon in the case of cast iron should be 1.824%. But because that cast iron picks up sulfur and carbon from the charcoal which you are using for burning, the percentage of carbon increases, and because of which the final casting what you get will be very much brittle in nature. So that is the problem associated with this kind of furnaces. The third disadvantage is that there is a loss of iron, silicon and manganese taking place due to oxidation. So what happens is that you see that the cast iron is being melted, and which is slightly open to the atmosphere. It reacts with the oxygen present in the atmosphere to form oxide. That's why it leads to the decrement of the final casting what you get and its properties. So this is a limitation, and its precise control of composition is difficult. Because of these two reasons, the final casting what you get, its composition will be not as what you had expected to, and even the environmental pollution takes place. So if you have a cupola furnace, you will see that enormous amount of smoke comes out of that furnace, which leads to the environmental pollution. So these are the limitations of cupola furnace. The third type of furnace what we are going to discuss today is the electric arc furnace. So in today's class we have started with the crucible furnace, which is a very simple type of furnace. We have moved ahead with the discussion about the oldest type of furnace called as the cupola furnace. Cupola furnace is advantageous because the cost is very lesser. The operating cost is also very less. No much skilled labors are required. You will get the metal continuously, but importantly, there are some disadvantages or limitations associated with it. The limitations are that the close temperature control is not possible. Composition control is also not possible, and it will lead you to some kind of environmental pollutions also. So those are the limitations of cupola furnace. Let us go ahead with the next technique called as the electric arc furnace. And hence, from this type of furnaces, electricity is being used for melting of metal. In the previous two furnaces, charcoal was used to melt the, or to produce the heat, or gas was used to produce the heat. In this and the next technique of melting the metal, we make use of the electricity. So coming to the electric arc furnace, graphite electrodes are there, and arc is created melting the charge. So you can see this is the construction of the electric arc furnace. These are the electrodes. The graphite electrodes are used. You pass electricity to this, and there is a arc being developed in between these electrodes. So because of this arc, the temperature rises and it will melt the metal here. If you see the construction, there will be a charging door. It is through this door that you introduce the charge or the solid metal. These are the graphite electrodes. It is consumable graphite electrodes. That means with the period of time, it goes on consuming, or the height of this graphite electrodes goes on decreasing. Then there is a slag door. It is through this door the slag or the impurities are being removed out. Then there is an oxygen inlet, so for the combustion to occur. And there is a tapping sprout, that is through this the liquid metal is being taken out or tapped out. And this whole complete vessel is made up of steel with internal refractory lining. The inside portion of this steel vessel is made up of kind of refractories, while outside it will be made up of steel. So this is the construction of electric arc furnace. The same thing is been written in the form of sentences. Graphite electrodes are there, and an arc is created melting the charge. Steel vessel with an refractory lining is there inside. Removable roof is there. There is a removable roof over here. This is the removable roof, or this one, this one can be removed out. A charging door is also provided. The slag door is to remove the slag, while a tapping sprout is there to remove the liquid metal. So this is the construction and working of our electric arc furnace. These four images I have placed in front of you to have a clear meaning of how the melting is being done inside the electric arc furnace. First is the initiation of arc. You can see that those three poles what you can see are nothing but the graphite electrodes, consumable graphite electrodes, and in between that you can see that arc is being used for melting of metal. You can see the charge, the solid charge, it is getting melted. So that's called as the initiation of arc. Second one is the intensifying of the arc. Once you pass the electricity to a higher extent, you will see that the arc has been intensified, and from a little bit distance view you can see the image, or you can see the scenario like this. Then the third one is metal ready for tapping. Once you have melted the metal, this metal is being ready for tapping. So next one is tapping of the molten metal. You can see that the metal is being tapped outside and it is being taken to the point at which the pouring has to be done. So these are the different steps which are involved in our electric arc furnace. What are the advantages of this furnaces? The advantages of these furnaces is that it is used for both ferrous and non-ferrous metals. So we have learned that the first technique, that is crucible furnaces, is basically used for non-ferrous metals. Cupola is used for ferrous metal, while this type of furnaces can be used for both ferrous and non-ferrous metals. Then close control of temperature is possible. So if you require the temperature of the liquid metal to be around 1501 degrees Celsius, you can achieve that by using this type of furnaces. While in the earlier two cases, it is little difficult. If you want 1501, probably the temperature might be around 1430 or 1450 degrees Celsius only, or sometimes it can be even 1550 degrees Celsius. So the close tolerance or the close temperature control which you want to have is achievable by this type of furnaces. Then precise control of composition is also possible. Why? Because here there is no pickup of carbon, no pickup of sulfur, no pickup of oxygen, because of which the composition of the final metal casting what you get will be controlled. Okay. And then the metal can be melted in short duration of time, because you are using electricity. Immediately you can melt the metal, and that reduces the cycle time, and metal quality is also very high. So if you want to get a quality metal casting, you should go for this type of furnaces. But the limitations of this technique is that high power consumption is there. So you have to supply power, and power is used in enormous quantity in the case of our electric arc furnace. So that's why high power consumption, high melting cost. So because high electricity is used, amount of electricity is used, high melting cost will be involved in it. High installation cost. To buy out this type of machine, it will cost a lot, and chances of carburization is there. Only one point, that is chances of carburization, means that since you are making use of graphite electrodes, graphite is a source of carbon, and that can enter into the melting metal and can lead to a problem called as carburization. That means the carbon can enter into the melting metal, and once the casting has been done after solidification or after pouring, the carbon content also will be high, and because of which the metal will be slightly more brittle or more brittle in nature. So this is one disadvantage or limitation what I can say that in type of this electric arc furnaces can occur. So these are the three type of furnaces what we have discussed. Now the fourth important type of furnace what we are going to discuss, which is there in your syllabus is the induction furnace. So I would like to ask you all to pay your attention to this type of this technique, that is the induction furnace. So the basic principle on which this induction furnace works is electromagnetic induction. You might have experience, or you might have a knowledge about what is this electromagnetic induction. In our elementary school, we have learned that when there is a wire and you pass electricity through it, that electricity is called as the primary current, and that electricity creates a secondary electric field around it, which is called as a secondary current. To demonstrate that principle, I have put this over here. So suppose if there is a coil like this is a coil, and if you pass the electricity through it, that electricity what you pass is called as the primary current, and it results in the development of a secondary current like this, which is perpendicular to the motion of the primary current. This principle is being used over here to melt the metal. Okay, so that's what is written. Principle is electromagnetic induction. High frequency current is passed through water cooled coils. So here if you see the construction, these are the coils what I want to say. These coils are moving in this direction. We have taken the cross sectional view, and you are water cooling it also. So these coils are not just kept in room temperature, it is water cooled also. Okay, so high frequency current is passed through the water cooled coils. These are the primary coils. copper induction coils made up of copper. Secondary currents are induced in the metal charge by electromagnetic induction. So once you pass the primary current of low frequency through this, you will see that a secondary current gets introduced inside this area, and inside this area you have introduced your charge, that is the metal, solid metal. The metal charge offers a resistance to the passage of the secondary current. So what happens is that the secondary current what has been developed will undergo or will face a resistance from the metal charge what you are placed inside. So this metal charge will not allow the secondary current to pass through it. So what happens is that the secondary current will pass through the solid metal charge and will heat it up because of the resistance what it is trying to produce. And in that manner, the heat develops so high that it melts out and it becomes liquid. So this is the technique that is being used in the case of your induction hardening or induction furnace. I will again tell you the features. So this is the cover, and this is our furnace. So there is copper induction coil. These are the coils. These are moving in this fashion surrounding the crucible or the vessel. And then this is the refractory metal. Inside there will be a refractory material, and then the molten metal arrows indicate the mixing action. So this action, what this angle or the arrow mark shows that the charge is getting mixed up. This is one more advantage of using this induction furnace, is that there is no requirement of mixing the metal charge or the molten metal separately. It is because of that secondary current or the electromagnetic induction or magnetic currents, the metal which is present in the liquid form will get stirred by itself, and you will get a uniform mixed molten metal, and then you can use it for pouring. This is an advantage of using this type of furnace. So these are the construction details and working of the induction furnace, and I have put this image just to show you how it is in practical or in a real view. So this is the copper coils, and inside there is the crucible, that is the crucible, not the metal, and inside that crucible there will be a liquid charge, that will be the metal charge in the form of solid or liquid. You pass the current through it, the crucible will get heated up, and in turn the metal charge will get heated up, and it will be ready for pouring. So this is what the pouring or the tapping is being done. Sorry, it is not pouring, it is the tapping. The metal is being poured into a ladle. This ladle will be taken out and moved to the place at which the pouring will be done. So this is that image. And again, in the induction furnaces there are two types. One is called as the core type, Corliss type, and the other one is core. In the case of Corliss induction furnace, what we have just discussed till now are called as the Corliss type of induction furnace. Here, high frequency is being used. The frequency of current is higher. Water cooling is there, and good stirring is being seen. So these are the features of Corliss type of induction furnace. Corliss means there is nothing there at the center. So Corliss type of induction furnace, it makes use of high frequency, water cooling is there, and then there is good stirring operation by itself that happens in the case of Corliss induction furnace. While in the case of core induction furnace, which we are going to learn now again, makes use of low frequency as compared to this one. Low frequency is used. Coil surrounds only the small portion of the unit. Here you can see that the coils are surrounding the complete portion of the crucible, while here in the case of low core type of induction furnaces, the coil will be surrounding only small portion of the unit, and it is used for basically for non-ferrous metals. I'll show you how does this Corliss and core type of furnaces work or construction is. So this is the Corliss type. Just we have discussed this in the previous slide, the same one, Corliss type. So you can see that here the contact of the coil around the crucible is to a larger extent. So you can see that to a larger extent the coil is surrounding the crucible. Here we make use of low frequencies, and you see that there will be a water cooling also in the case of our Corliss type. But in the case of core type, you will see that the coil is not in direct contact with the crucible, it is placed somewhere else, and the secondary current will be made somehow to move into the charge and melt the metal, or otherwise the metal will be slowly moved in throughout this coil like this, only partial way, and it gets melted up and moves up like this. So this is called as the core type of induction furnaces, and basically it is used for non-ferrous metals. This one is used for non-ferrous metals, this one is used for ferrous metals. Okay. So these are the two type of induction furnaces what we have. One is called as the Corliss type and the other one is called as the core type. The basic difference is that in the type of Corliss furnaces, the copper coils contact the crucible to a larger extent. In the case of our core type, the copper coils will not contact the crucible to a larger extent, and it is a little bit offset to the crucible. So like that. Then what are the advantages of using this type of furnaces, that is induction furnaces, is like this. Narrow melting vessels. You can see that here the vessels which we use for melting the metal will be narrow. It will be not so huge like our cupola furnace or crucible furnaces. It will be narrow, but it will be very much increased in the height, right? So low D to H ratio. So if you see the diameter to the height ratio, it will be very much lesser. That means the height will be more and the diameter will be lesser. And lesser oxidation. Since you have a bigger vessel, one small area of the metal will come in contact with oxygen. So that's why lesser oxidation. Low crucible thickness. The thickness is very much lower. The crucible thickness is expected to be lower because otherwise the secondary current will not develop so easily. That's why it is expected that the crucible thickness is very much lesser, and it is very much less expensive also. This type of furnaces are less expensive. No stirring is required. It will occur by itself. That's an advantage of this one. I have discussed it earlier also. Uniformity of melt composition. Since stirring takes place by itself, uniformity of the melt composition happens. Melting takes very much less time. It takes very much less time. Within seconds the melt will occur. And no carburization. Since we don't make use of any charcoal, we are not making use of any graphite rods, no source of external carbon is there, and because of which no carburization is happening in this type of furnaces. That is an advantage of this type of furnaces. In fact, in many of the foundries, this is the new technique which has been used for melting of metal. What are the limitations of this type of furnace? The limitations is that high initial cost. So if you wish to take an induction furnace, you have to shell out a huge amount of money. That's why high initial cost is there. Sampling cannot be carried out because of the high rate of metal. In many of the foundries I have seen that when they are melting the metal, intermittently they take out a sample of that metal and do the analysis to see what is the composition of that metal. So that is not possible in this case of induction furnaces because it will take it will be totally enclosed many times, and the whole process will occur so quickly that you have no time to take the sample out of that liquid metal. That is a disadvantageous fact here. And machine is usually restricted to only one alloy since charge changing is difficult. So if you have an induction furnace, it will be dedicated only for one type of alloy. If you wish to change the alloy, again it is a slightly difficult affair. You need to clean the inner portion of that furnace and then do the change over to the other alloy. So that is one more difficulty which is associated with this type of furnaces. So this completes your induction furnace which is there in your syllabus. And just to go ahead and to have a flavor about all the different type of furnaces, one more type of furnace is there called as a rotary furnace. Here the furnace is in this horizontal manner. It is being rotated and the burner is there and the fuel plus air is being introduced inside this and the exhaust comes out. This rotary furnace is revolved very much slowly. For example, 1 revolution per minute, in such slow speed that furnace is being rotated, and because of which the hot gases and fuel what you are passing will burn that charge which is there inside, and you will get the liquid metal out of it. So that's called as a rotary furnace, and the inside the layer of the rotary furnace will look something like this. The inside layer of that furnace is having a refractory lining. That's what I'm trying to depict here in this image. So that is the inside lining with refractory. So inside lining will be refractory. Of course, this is not there for a syllabus, just for making you to understand the different type of furnaces I have put here. Okay. So the next point what we have to discuss is the selection of the melting furnaces. On what basis you are going to select the different type of furnaces? Now you are equipped, or we have discussed about the different type of furnaces. We can either go for crucible furnace, we may either go for cupola furnace, we can go for electric arc furnace, we may even go for our the latest, that is the induction furnaces, or even rotary furnace, or even resistance furnace. So on what basis you are going to select which type of furnace is being mentioned in this slide. The things are that initial cost of the furnace, that is what amount you are going to you want to invest on the furnace will decide the type of furnace what you want to take. So that is the initial cost of the furnace. So if you see, the cupola furnace is having the least cost. So that's why cupola furnace is used in many of the foundries. The second point is that fuel and operating cost. What type of fuel is being used in that furnace, you have to make ensure. So if you don't have charcoal supplying source, then you shouldn't go for the first one and the second one, that is the cupola furnace. If you have electricity in surplus amount in your region, then you can go for electric arc furnace or induction furnace. So based upon the type of fuel or the source of power to melt the metal, the type of furnace will be selected. Kind of metal or alloy to be melted. So depends upon what type of metal you are melting, whether you are melting ferrous metal, non-ferrous metal, that will decide or make you to select or go for a particular type of melting furnace. Melting and pouring temperature of the metal to be cast. So the temperature at which you are working also will define the type of furnace what you have to select to. Quantity of metal to be cast. How much quantity of metal you want to melt. So that will define the type of furnace what you have to take. So for example, if you have to melt a large amount of metal, you should go for cupola. Small amount of metal, you can go for induction furnaces. Then maintenance cost. How much amount of maintenance is to be done on that furnace will define the type of furnace you have to go for. And the quality of the molten metal is expected to. What type of quality of molten metal you want to produce. If it is very high quality, you should go for induction furnace. If it is of low quality, you can either rather go for crucible or our cupola type of furnaces. So these are the things what you should keep into your mind when you go for the different type of selection of the different type of furnace. And here, this is the last slide what I have put. The different type of furnaces, the mode of melting, that is the source of fuel which is used to melt the solid charge, and the applications of those type of furnaces is being mentioned. So for example, crucible, mostly it is used for alloy steels except steel. So I have told that earlier also. Cupola furnace for cast iron and steels we make use of. Then electric arc furnace for non-ferrous metals and even steels we can make use of. Induction furnaces for non-ferrous alloys. Then for again ferrous metals, there is again two type of induction furnace, low frequency and high frequency. Then resistance furnace is there, rotary furnace and reparatory furnace. This is just a table which will help you to select the different type of furnaces for your requirement. So with this, the third unit, my part, that is the special molding processes are covered, plus the melting technique for melting furnaces which are used for melting of metal is also completed. So for your examination, you should remember the different type of special molding processes, that is shell molding, investment molding, then pressure die molding, gravity molding, then centrifugal molding and continuous molding technique or casting techniques. And then under the melting furnaces, you should concentrate more on the induction furnace. And under that, there are two types. One is Corliss type and the other one is core type. So this is the portion what you should be knowing. Apart from that, you should be knowing the different working of the different type of furnaces which is available in the slide. I will be giving that slide if you want, and on what basis you will be selecting the different type of furnaces also you can have a knowledge about it. So with this, the part of the unit number 3 is over. Okay. In the next class, we will discuss about the remaining portion of the unit number 2, that is core, C-O-R-E, core. Okay. Thank you. Which is used for producing of hollow castings. That we'll discuss. Okay. Thank you.